Hey everyone, so welcome to day 2 of trigonometry. We're going to talk about radians here. All right. Radians, okay? This is a new topic. Well, not a new topic. This is a review of a topic from geometry, but maybe it's been a little while since you've seen some geometry, so here we go. So the way I like to introduce radians is I like to have my students consider a circle, okay? And think about that circle that I've got right here, okay? This circle right here, maybe, with a radius of r, okay? So there's our radius r. I want to know how many radiuses, which is really the plural is radii, how many radiuses does it take to get around the outside of a circle? Okay, so again, if you think about measuring this with like a piece of string or something like that, okay, and then wrapping that string around the circle, like, you know, this, you know, and counting off how many of those pieces of string it takes to get around, you'll see that you'll always end up with a particular number of radii, and it doesn't matter whether the circle is a bigger circle like this one or a smaller circle like this one. And the reason for that, right, is because a bigger circle has a bigger radius, right, and a smaller circle has a smaller radius. Okay, and so as a result, the number of radii it takes to go around the outside of the circle will always be the same. So how many is it? Like I said, it's a little bit more than 6. Okay, so it takes a little bit over 6 radii to go around the outside of the circle. But the question is, why? Okay, well, think about what does it mean to go around the outside of a circle? To go around the outside of a circle, that is the circumference formula, okay? Circumference goes around the outside of the circle. That measures the actual, like, distance, right? So the circumference is 2 times pi times the radius, okay? But also we can go around the outside of a circle using, like, 360 degrees, for example, okay? The difference here, though, is that 360 degrees is true for any circle regardless of the radius, whereas the circumference, it changes with the radius. But still, in some sense, right, they both kind of measure going around the outside of the circle. So if we set this 360, which kind of measures around the outside of the circle, equal to that 2 times pi times the radius, we end up with this little equation here. And in fact, that is our equivalence between a measure in degree and a measure in radian. So that idea, the radius here becomes the word radian, okay? And that allows us to kind of speak generally about a circle with any size radius, okay? So degrees and radians are 2 different ways to measure an angle, okay? So degree, radian are 2 ways to measure an angle. I'm going to write that down. Just like if you wanted to measure a length, you would use inches or centimeters, or, you know, and inches and centimeters are just 2 different ways to measure the same thing, right? You have inches, you know, which are based on the standard system, and centimeters, which are based on the metric system, okay? Once we have this equivalence, then we can come up with all sorts of other relationships. For example, here, what would 180 degrees be in radians, right? Well, to get from 360 to 180, we have to do 1/2, right? And so we'll do the same thing here. What's half of 2 pi? Well, half of 2 pi is just 1 pi, or pi. And so, in fact, 180 degrees is just pi radians. Oops, I lost my hat. There we go. All right, so like, there's my little thing. Like inches to centimeters, we can convert radians to degrees as well, okay, and degrees to radians, okay? So there's conversions here. All right, I don't know the conversion for inches to centimeters, but I do know the conversion for radians to degrees. If you want to convert from degrees to radians, you'll use this. You'll multiply your degree measurement here times pi over 180. Okay, if you want to convert from radians to degrees, you'll multiply your radian measure here by 180 over pi. Okay, you can kind of see the difference there. Okay, and this has like some background if you're going to feel like you're going to have trouble remembering that. You know, think about it this way. If you talk about, like, you know, if you have 30 degrees, right, and you want to get that into radians, you'll need to multiply this by something with a degree measure in the denominator, so that way the degree symbols will, you know, kind of cancel out and convert you to radians, okay? So you can just use that, the 180 degrees there and the pi. Okay, and that comes straight from this little, you know, conversion right there, that little equivalence right there. And again, you just multiply it out. Okay, so you get, you know, 30 pi over 180. And we'll do some examples of that here. So you just, you know, you get 30 pi over 180, and then it's just up to you to simplify this fraction right here. For radians to degrees, the same kind of principle too, okay? You know, 180 degrees is equal to pi radians, right? And so again, if you have, like, I don't know, 3 pi radians, and you want to then multiply. We want to eliminate this radian unit here, so you put the radian measure that you know on the bottom, and its matching degree measure on top. You put it over 1, and then the radians will cancel, and you just multiply across the top, multiply across the bottom. The pi's will cancel too, and you just do 3 times 180 there, so 540 degrees. Okay, like that. Anyway, let's do some actual conversions here. So convert from radians to degrees, or degrees to radians. So here we got 20 degrees, so we'll do 20 degrees over 1 times 180. Nope, that's the wrong one. Pi over 180 like that. And so we'll have 20 pi over 180, okay? Now, we'll simplify this fraction, but we never really multiply that pi through. Sometimes you might, but for the most part, you leave the pi out, okay? So let me calculate here with the calculator. I'll just show you that if you want to use your calculator to do this, you don't really need it, but 20 divided by 180, and then hit math, enter, enter. Notice I left the pi out, so it's 1/9 if I just have 20 over 180, so that means then when I come to here, come on baby, then it will simplify to just 1 pi over 9, or just pi over 9, like so. Okay, and we can do the same thing here for 315. It'll be 315 times pi over 180 degrees. Okay, again, the degrees would cancel there, and so we'd have 315 pi over 180, which is 7 pi over 4. I believe 7/4. 7/4. 315 over 180, 7/4. Mash the keypad here. Yep, 7/4. Okay, perfect. Now negative 60, again, don't fret if it's negative, right? We'll just do negative 60 over 1, and again we'll multiply by pi over 180 degrees. Again, the degrees will cancel because we have a degree in the numerator and the denominator, so that unit will cancel out. And then negative 60 divided by 180 will simplify to negative pi over 3. Okay, so they still have that negative in there, indicating, you know, if we were to like write this angle out, we'd be, this is like a counterclockwise angle here, right? Or no, not counterclockwise, sorry. Clockwise, because it's a negative angle. Okay. Oof. Okay, rotation for the angle there. All right, let's keep going here. Let's try some of these radian measures. So pi over 8. So we're going to take that pi over 8, and this time, since this is in radians, okay, we will multiply by 180 degrees over pi radians. And so now the radians will cancel, the pi's cancel. That kind of clues you in. Not every radian measure has to have a pi in it, but like 99% of them will. Okay, and so we just need to simplify the 180 and that 8 there. Okay, so it's going to be 90 over 4, which is 45 over 2, which, you know, is 22.5 degrees. Like that. Okay, the next one here, 4 pi over 3, again, multiply by 180 degrees over pi. So again, the pi's will cancel. 180 divided by 3 is, so 180 divided by 3 is going to be 60, but then times that 4 will be 240 degrees. Okay, and then negative 9 pi over 2, again, times 180 over pi. Sloppy pi there. Pi's cancel. 180 divided by 2 is 90. 90 times negative 9 is negative 810 degrees. And again, a negative angle. Okay? All right. Last thing here I want to show you here is just coterminal angles. We talked about these yesterday, right? In degrees, we found we could do coterminal angles, that is, angles that share the same terminal side, right? They, you know, kind of end up in the same position when you rotate there. In degrees, we just add or subtract 360, and we end up in the same kind of position. So then what would that be like in radians? Well, what's equivalent to 360 degrees in radians? 2 pi. So we're going to just add or subtract 2 pi to our radian measures to get coterminal radian angles. So for example here, if we've got pi over 8, let's find a positive coterminal angle. So we'll do pi over 8 plus 2 pi. And let's find a negative coterminal angle. So we'll also do pi over 8 minus 2 pi. Now, to add these two things together, we got some problems because they're not going to be able to add together because we need common denominators, right? From that rational functions unit, we need common denominators here. These, so what can we do? Well, you could in your calculator just do 1/8 plus 2 and then throw a pi next to the answer once you do that. So that's one option, okay? So if I just do in my calculator here, Parentheses, always parentheses around your fractions. 1/8 plus 2, hit enter, then math, enter, enter. You can say it's going to be 17 pi over 8. Okay. Alternatively, though, you know, we're going to be big boys and girls here. We're going to try and actually do this. So pi over 8 plus, and then we'll make this 2 pi over 1 times 8 over 8 to get that 8 in the denominator. 8 in the denominator there that we want. And so it's going to be pi over 8 plus 16 pi over 8. And this is 1 pi over 8 plus 16 pi over 8. So it becomes 17 pi over 8. Hey, that's what we saw in the calculator. And then same thing here. Pi over 8, oh, not plus, minus, and again, 2 pi over 1. We'll multiply by 8 over 8. And so again, we get pi over 8 minus 16 pi over 8. 1 pi minus 16 pi is negative 15 pi over 8. Okay? And so there are our coterminal angles. If you were to recalculate these here into degrees, I'll do that just real quick here using my calculator. We would get 382.5 degrees here, and negative 337.5 degrees here. Okay, which if we go back up to number 4, right, number 4 was pi over 8, and you'll notice 22.5 was that same measure in degrees. And if I do 22.5 plus 360 degrees, you get this angle. And if I do 22.5 degrees minus 360, you end up with that angle, okay? So whether you decide to do coterminal angles with the radians, or whether you decide to convert to, degrees and then do coterminal angles, it's all going to end up being the same thing. Okay, so it's kind of nice. All right, but we do need to get comfortable with radians, especially if you're planning on going on to pre-calculus or calculus. You will need to be comfortable with these radians. And we'll do more practice with this throughout this whole unit. It's kind of a fundamental measure we're going to use. So thanks, guys. Have a good day. And let me know if you have any questions for the homework or anything. Bye.